Hello, good morning, students. This class is for revision of Unit 2 Friction. As we have discussed a few of the basic concepts of friction, we will be directly going to the problems and solving the problems. Just let us have a recap of what we discussed. We discussed about frictional force. What is frictional force? It is resistance offered by minutely projected particles. I've shown you yesterday that if the objects actually look smooth, but if you see it at microscopic level, the surfaces are bit rough like this. So these minutely projected particles offer resistance. They try to stop the motion. So that is nothing but your resistance force. It's a kind of reaction force. So in friction we have limiting friction. We have already seen what is limiting friction. Limiting friction we have seen, and also we have seen static friction and dynamic friction and their types, sliding and rolling. In dynamic friction again we have sliding friction and rolling friction. Now let us move to the later part. Laws of friction also we have seen yesterday. These are the laws of friction, and before that we can see here coefficient of friction. What is coefficient of friction? This F is nothing but limiting friction, and this N, or in some textbooks it is mentioned as R, it is normal reaction or reaction. It will be always perpendicular to your contact surface. Okay, so ratio of this limiting friction and normal reaction will be coefficient of friction. This mu is nothing but your coefficient of friction. Here you can see coefficient of friction. Then we see laws of friction. Laws of friction we have already seen, just we will just revise it. It always acts in opposite direction. These laws are about friction, frictional force or friction. Opposite direction to that in which body tends to move. Tends to move, that means the direction in which we are expecting the body to move, or the body is trying to move, or the body is about to move. Suppose by seeing the forces we can say that the body will move towards right. That means the friction will be towards left, opposing the motion. Now till limiting value is reached. What is limiting value? If you are applying force on a body or a block, if you are applying light, very less force, the friction force will be very less. If you increase your force, friction force increases. Suppose for example here, just see here, this case, if you apply force P, this force P we are applying, if you apply force, if you increase the force little bit, this friction force will also increase. If you increase the force, again friction force increases. If you increase by some more quantity, friction force also increases. But at some time there will be some limit to your friction force. After some time the friction force stops in fails in stopping the motion. The friction force fails in stopping the motion and the body starts its motion. So this force at which the friction force stops, or the friction force fails in stopping the motion, is the limiting value of friction. It is called limiting friction. or limiting value of friction. Okay, so that is limiting value. And regarding that, we have a law: till the limiting value is reached, the magnitude of friction is exactly equal to the force which tends to move the body. Friction force adjusts itself according to the force. How much the force is, the friction force will become that much. Suppose you are applying 5 newtons of force here, the friction force will also be 5. If you are applying 10 newtons here, the friction force will also be 10. This procedure or this kind of game goes on till the limiting value is reached. When once the limiting value is reached, after that friction force can't increase, it cannot increase. Now next law is the magnitude of limiting friction bears a constant ratio to the normal reaction. What is the magnitude of limiting friction? What is limiting friction? F. Bears a constant ratio to normal reaction. What is normal reaction? N. So this ratio is constant, they mean to say. What is that constant? Coefficient of friction. We have already seen. And now the force of friction depends upon the roughness and smoothness of the surface. If the surface is smooth, like in case of your carom board, what happens? You just sprinkle the powder for smooth uh, sliding of your coins, or striking the coins is to in an easier manner. You sprinkle the powder, so because of that the friction will be reduced. And in case uh, whenever you might have seen some oil or some sticky substance, if it is fell on your floor, the friction is reduced. Because of that, we slip easily on the floor, because the surface now it has become smooth, there is no friction or roughness on the surface. We fall down very easily, we slip our feet there. It is because of smoothness of the surface. So that is all, and about the smoothness or roughness. And after that we have fifth point: the force of friction is independent of area of contact. It does not depend on area of contact between the two surfaces. After that, after the body starts moving, the dynamic friction comes into play. These all the laws are, we're talking about static friction. When the body starts moving, what happens? It is not under static friction, it is under dynamic friction, the magnitude of which is less than that of limiting friction. The dynamic friction will be slightly less or lower. And for lower speeds, the dynamic friction will be, we have discussed about this. But when the case in the case of high speeds, it will be less, the friction will be less. Okay, when the body is moving with high speeds, the friction will be less. Now angle of friction also we have seen. Angle of repose, it is not much important. If it is required in problems, I will just come back here and again tell you angle of repose. If you want, you can just refer here, it is very easy in your text PDF, or you can take the screenshot of this text and you can read it and go through it. Let us go to the next topic. Let us try first problem. A block weighing 1000 newtons I hope you are able to see it clearly. Block weighing 1000 newtons rests over a block B. What is this? Block A. This block A, how much is its weight? 1000 newton, rests over block B. It is on block B. Which weights? The weight of block B is 2000 Newton. Block A is tied to the wall. You can see clearly here. Actually this figure is not given in the question. We have to draw this. Just we can imagine, right? Block A 1000 Newton. It is resting over block B. Just draw block A. It is resting over block B. This is block A. And this block A is tied to the wall. Weights already mentioned. And again block, if the coefficient of friction between block A and B is 0.25, between block A and B here, that means here, ikkada, between A and B, it is 0.25, and between block B and floor, it means here, between these two surfaces, is 1/3. What should be the value of P to move block B? Anyways, you know the block A will not move in right direction because it is already tied, but we can move block B, right? How to move it? By applying some force. It's obvious. So how much that force should be in order to move block B? You know that if the block B would have been single individual, then it would have been easier to pull block B because the friction force on block B will be from only the surface. But now that is not the case. Even between block A and block B there is contact surface, and here also there will be a friction, and here also there will be friction. Okay, so we have to take care of these two friction forces, and then we have to find the minimum required force P to move the block B. Let us see how we can do this. Also in the question they are asking two bits. When P is horizontal, how much it should be? And if P acts 30 degrees upwards, like this, instead of horizontal, the P is like this, 30 degrees. What should be the angle? So let us see the question now. Solution, sorry. Now the free body diagram is already drawn. We have seen it. First of all, the main important thing in mechanics is to draw free body diagram. It is very important. Here you cannot understand everything. You have to draw free body diagram. When you draw the free body diagram, it will be easier to understand what is actually the problem. So we are drawing the free body diagram. 200 Newton block is drawn. After that we are drawing 1000 Newton block. Now what are all the forces on your 2000 Newton block? First is force P, then we have 2000 Newton weight. Here you can see 2000 Newton weight here. After that we have, because of this weight, there will be a normal reaction N2, right? And after that, because we are applying a force P on this body is tending to move right side, so the friction force will be left side, opposite direction. It is simple and clear. Now going to the block A, 1000 Newton is the weight, so there will be normal reaction N1 for that. This same N1 or 1000 Newton will act in towards both the bodies. N1 will act upside, also downside. Okay, then there is a string also tied to the body. It will be in tension because you are trying to move this body, and this body will try to move this body, our body A. So because of this, the string will be in tension, and the string will try to hold body A, and the force will be in this direction. The tension force will be in this direction. So we are writing tension force in this direction. So now let us solve the problem, because yes, for when we consider body B, the friction force is in left side direction for body B due to the ground surface, and due to block A, the friction force is left side, because our body is moving in right side direction. But when we consider block A, what is happening? When we consider block A, the friction force will be in opposite direction, not in left side direction, it should be in right side direction, because when the body starts moving, block A will be at rest, block B will be moving. So if you consider the motion of block A with respect to block B, suppose this is one bus and this is one bus. This bus is moving forward and you are sitting in this bus. And you are looking this bus, bus B. You feel that your bus is going backward, right? When suddenly you see the other things around you, or the road or the signal or trees or something around you, then you feel and realize that your bus is not going backward, but bus B is going forward. So that why you felt that your bus was going backward? It was you were looking bus B. With respect to that, you were calculating your motion, and you are feeling that your bus is going backward. So same is the case here. When you see block A with respect to block B, block A's motion is in backward direction, like that. So the friction force will be in right side direction. Or if you don't understand this, don't take that much tension. This F1 and N1 will be in pairs. Whenever they are in between two bodies, if N1 is upward, downward, N1 will also be there in downwards direction. And F1, if it is in right direction, it will also be in left direction. Got it? Now let us solve the problem. First of all, we just have to take what are all the vertical forces. Just calculate. Just we are taking vertical forces. What are all the vertical forces when we consider block A? We are considering block A, and on block A we are considering vertical forces. What are all the forces? 1000 Newton, N1, only two forces. So N1 is in positive direction, positive, upward. N1 is upwards, na? So it will be N1, positive N1 plus N1, and 1000 is in downward direction, so negative. That will be equal to 0. So from this we can get the value of N1. Simple. Now we will go to the next part. We know that since F1 is limiting friction, F1 by N1 is equal to mu. So F1 is equal to mu N1. So from here we get the value of F1 is equal to mu into N. What is the value of N1? 1000, already calculated here. So from there we will get the value of F1. Now this here one point is missing. We are considering horizontal forces or sigma h. So it is not missing here. I have missed this. Here it is written sigma h or horizontal forces. So if we consider horizontal forces, what are the horizontal forces on block A? One is F1, the other is T. So what is F1 here? It is positive or negative? It is positive. And what about T? It is negative. So F1 minus T is equal to 0. So from there, F1 value we already know, So from there we get T value. T is equal to F1 is equal to 250 Newton. Now we are considering the equilibrium of block B. Are you able to see block B? Yes, you are able to see, because I can see, you can also see. So consider the equilibrium of block B. So first we are taking the vertical forces. Sigma V means vertical force, sum of all the vertical forces. Sigma V means sum of all the vertical forces. So we have N2, we have F 2000 Newton, we have also N1. If you zoom in here, you can see. Let us zoom in here. I will show you by zooming in. We have N2, we have 2000 Newton, we have also N1. N1 is acting in pairs, upside also and here on the block B also. So this is already considered done. Now we have to consider this one. So N2, 2000, N1, three forces. Can you see any other force? No. So let us go there and write all the forces there. N2 is positive, so N2, 2000 is negative, N1 is negative. Just adding all those forces, and N1 value we already know. From there we can find out the value of N2. Now again we know that F2 is limiting friction for block 2 or block B. So from there we can find out F2 is equal to mu into N2. N2 value we already got it. So from there we get F2. Okay. Now considering horizontal forces for block B, what are the horizontal forces? P, F1 and F2 are negative, they are stopping the motion. So P minus F1 minus F2. So F1 F2 we already know, just add the two forces, you get the value of P. Okay, when P is inclined it is just simple, no need to bother about that. Just have a look and let me know if you have the doubts. While considering P, we will just resolve it into two parts. If it is inclined, this is the case here, it is the case. Let me zoom in for you. Let me zoom in here. If P we have to resolve in two components, P cos theta and P sin theta. Theta value we already have, it is 30 degrees. So P cos theta and P sin theta. So in your vertical forces, one force will be extra here. Whatever you have done in the previous bit just now, what we have covered or discussed in this problem, it will be, this one thing will be extra, P sin theta in the vertical forces for block B. And in horizontal forces we were adding P, but now we will not be adding or subtracting P, just we, in place of P it will be P cos theta. It is simple, just do this and you will get the remaining part or part B of the problem. So thank you students. Now in the next video we will try to see the next problems of friction, hopefully wedges. Thank you, and let me know if you have any doubts.